Good morning, ladies and gentlemen, here in New York. Good morning, good afternoon, good evening if you're following this day 3, first general session of the day out there on the World Wide Web via SYS-CON TV. We have got Akamai, as I said, up next. Always great presentations from Akamai. Gary Ballabio, a true supporter of Cloud Expo. I think you almost presented at every single one. Cloudy with a chance of success. I don't know about those very hesitant 3 dots. I think it's all going to be successful. Let's give it up for the product line director of all things cloud at Akamai, Gary Ballabio.
All right.
Very nice audience.
Thank you, sir. All right, so as Jeremy said, my name is Gary Ballabio. I'm a product line director at Akamai Technologies, and I cover our enterprise cloud solutions, essentially packaging up and gearing Akamai's products towards cloud adoption that you all are familiar with. So today I'm going to be talking about how Akamai is a complementary offering to any sort of cloud service that you adopt, and how we can improve the reliability, the availability, the performance, and the security of those cloud environments. So in terms of an agenda, really quickly, I'm going to be talking about just some high-level trends about things that are driving cloud adoption, some really exciting statistics. Talk a little bit about the challenges related to adopting cloud services that you face, some of the solutions that Akamai has to address some of those problems. And then lastly, I'll talk a little bit about how Akamai can be a strategic component of your big data initiatives. So from a high level, I mean, even as the previous speaker said, these are really exciting times. More and more companies are embracing cloud services. They're seeing the benefits of cloud services as well in terms of the agility it provides, the reduction in complexity, and the ability to now focus on your own core revenue generation operations. Forrester launched a study, actually released a study in the beginning of this year. And according to them, they said that 41% of all companies are going to be adopting infrastructure as a service the next few years. And that's up from 29% of all companies who adopted infrastructure as a service in 2012. Right? So that's a tremendous leap. Also, from a platform as a service, they're saying that 32% of all companies around the world are going to adopt platform as a service in the next few years. And that's up from 19% in 2012. They're also saying that 60% of all companies are going to adopt software as a service in the next few years, and that's up from 45% in 2012. These are really exciting statistics, not only for the cloud providers who provide these types of services, the software as a service, the platform as a service, and the infrastructure as a service, but also for you all, right, to be able to benefit from their services, right, and being able to focus more on your core business, right? These are really exciting times. And then also the types of applications that are now popping up on these different types of cloud providers, on the public cloud, also software as a service. There are many different types of productivity types of applications, right? So you're looking at business intelligence, supply chain, productivity types, the collaboration types of applications, support applications, tax, operations management, IT management, right? The types of applications coming on board are really widespread, right? Which is helping companies save costs, and it's helping them improve productivity. Again, these are really exciting times. But all of these applications and all of the cloud services that are leveraged all have to deal with one thing, connecting the cloud services to the end users, right? And that's that little thing called the internet, right? Between the cloud services and your end user. And the internet itself is a complicated place, and we'll get into more details about that. And if you look at a lot of the conversations, even here at Cloud Expo, there's a lot of focus on optimizing the cloud environment. And there's a lot of good things that you can do in the cloud environment to essentially move the data faster out of your cloud environment and get it out across the internet. And that's really good, but there's not a lot of companies that are really focused on how can you essentially optimize the delivery of that application from a centralized environment to a global end user, or even just to a domestic end user audience, right, in the US? How do you optimize that? And then also, how do you standardize security policies to ensure that no matter what environment the application is actually being delivered out of, the same sorts of security rules are applying across all of those environments, right, no matter where they are? And what about the user experience? So what about users coming in from different types of devices, popping up across all sorts of locations around the world, coming in from all different types of connections? How do you optimize the experience for those specific users to ensure that they have an optimal experience as well? And what about availability and ensuring every single request is responded to regardless of the state of the origins? Right, so assuming you have an up and running origin infrastructure, right, the end user's request should always be responded to. And then lastly, what about getting real-time information into who is accessing those applications? What exactly are they accessing? Where are they coming from? What is the experience of those end users accessing that applications or those applications? There's a lot of companies that probably are focusing on some of these areas, but at Akamai, we're focused on all of these areas, right? And that's what I'm going to talk about today, is how Akamai focuses on each of these areas and the type of value that we provide in each of these areas as well. So it's important to think about these types of problems and addressing these problems from a business standpoint. So without addressing these sorts of problems, or without being able to run from a more centralized environment, it takes, money to solve those sorts of problems, right? So if you're trying to reach a global audience, there are certain things you can do to pop up, more infrastructure around the world. You could do things like cloud bursting, right, across different cloud environments, or even within the same cloud environment, right? That takes time. That takes operations, to actually set up, to support. And at the end of the day, it just takes money. And at the same time, if you don't address those problems, right, application adoption could suffer. Users are not going to utilize those applications. And then at the end of the day, productivity suffers. Productivity for your employees, productivity for your partners, for your customers, and even your own productivity, now dealing with cases and dealing with issues, coming in that need to be responded to. So it's really important from a business standpoint to be able to address the problems that come about from utilizing cloud services that are running over the internet. Now, in order to understand how Akamai can address these types of problems through the internet, it's first important to level set and just kind of get a basic understanding for how the internet itself works. So from a high level, from an end user standpoint, it's actually quite simple, right? I sit down, I open up a browser, I type in a URL, and I hit enter, and then voila, the web page shows up, right? It's all very simple. But as a lot of you in the audience are aware of, since you're IT professionals, the internet itself is not that simple, right? So when you look under the hood, the internet is a very complex environment. It's made up of networks, right? And these networks have to work reliably with each other in order to successfully move data from point A to point B, in order to move the data from the cloud environment down to your end user. And the governing protocol that is used on the internet to traverse data through it is BGP. Now, BGP is not necessarily a protocol that takes into account performance information, right? Because it's the network providers advertising routes through the internet, it takes into account costs more than it takes into account performance. So while there may be a very direct path that the end user could take through the internet to get to the cloud service provider, it's not necessarily the case. They may take a roundabout route to get to that infrastructure and retrieve the data that they're looking for. There are even times where the routes themselves can just break, right? There's times where they can get congested. There's peak periods through the internet that a lot of those core routes that users are traversing through get crowded. It's very similar to if you were to get directions to go from New York down to Washington, D.C. on Google Maps. It would give you some sort of default route, probably over 95. So if you were to drive there, and then if you were to hit construction zones, if you were to hit an accident, there's not much you can do, right, if you don't know other roads around that area that can get you around that problem, okay? Locals in the area may know, but you may not be aware of it because it's not dictated in the directions that you got. So very similar problems occur on the internet. So how can you get around those types of problems as they occur on the internet? So it's a similar problem. So from a cloud standpoint, it also introduces some interesting challenges. If I compare an application running in your corporate environment or running in the same location that you are in, it's going to be very reliable. It's going to be very fast. Right? Then once you take that same application and you move it out into a cloud data center or move it off-site, it's not necessarily the case that you're going to be accessing that application locally anymore. It's not going to be necessarily in the same building. It's not necessarily going to be across the street or even in the same state. Or heck, it's not necessarily going to be in the same country anymore. Right? So that distance just creates problems. It's the whole speed of light issue. Right? The further you are from the location, right, the more latency you're going to see and the reduction in performance that you're also going to observe as well. And not only that, the issues on the internet that I just talked about are also going to be run into as well. So these are the types of problems that Akamai is focused on. Right? We're focused on optimizing that internet medium to ensure that the access to the applications that you're putting out in the cloud are optimized. Then at the same time, when you push applications out to these cloud environments, it's now prone to threats. Right? So it's open. Now you have the vulnerabilities of distributed denial of service attacks. You also have the possibility of data getting stolen. There's a lot more concerns with now moving it off of your private network and onto a public environment and being accessed over the public internet. And then lastly, just in terms of visibility. So now that it's off of your infrastructure, getting access to a real-time feed of data and getting an understanding of who's accessing your application, what problems they're having, and just being able to troubleshoot in real time can be difficult depending on what you're doing and how you're accessing the application. So these are the problems that Akamai is looking at. So I'm going to talk about how Akamai can address a lot of these problems, and I'm going to break it up into 4 different areas. So first, I'm going to talk about performance. I'm going to talk about availability, mobility, and then end it up with security and then visibility as well. So first, talk about performance. So if you don't know who Akamai is, from a high level, Akamai provides a globally distributed platform of servers on the internet. Okay? Today, we have over 120,000 servers that are providing our service, and we're deployed into 1,100 different networks. Right, so we are deployed into the ISPs, where end users are accessing the internet from. We're also deployed into the Tier 1 backbone providers, right, where a lot of origins are, and also where a lot of the cloud service providers are as well. We strategically place our servers in the areas where the eyeballs are. Okay? It's not just a shotgun approach and just throwing servers out to anybody who will accept them. We're analyzing the internet, we're taking a look at where traffic is coming from, and we're putting our servers in strategic locations. We're also trusted by many of the world's largest companies, many of the top e-commerce sites, many of the top media and entertainment sites, many of the top banks. They all trust Akamai and they work with Akamai. We're a proven business model. And we serve anywhere from 15 to 30% of the world's internet traffic. There's a lot of people in the world who are going through our network on a daily basis, and they have no idea that they're going through our network. Right? It's a seamless service. On a daily basis, we're serving upwards of 12 terabits per second of traffic and up to 27 million hits per second at peak. And if you go to our booth here at Cloud Expo, you could even get a demo or get a real-time view into what we're serving right now on the internet. So let's go back to the challenge of moving that application out to the cloud data center. And we already talked about the challenges the internet itself basically provides when accessing that application. Akamai solves a lot of those problems with our globally distributed platform. So we have our set of servers out there. And the first thing that we do is ensure that every single end user on the internet can access the most optimal server for them at any moment in time. At Akamai, we are constantly evaluating the weather patterns of the internet. We're constantly taking a look at where are the bottlenecks and where are the congestion points on the internet. And we use that information to ensure that every end user can connect to the best server for them at that moment in time. We also use that to help us route around certain problems, which is something that I'll get into. So once the end user makes the connection to the best server for them, we next optimize the connection between the Akamai servers that are en route to the cloud data center. And we're doing all sorts of things of optimizing the route and optimizing the TCP connection there to essentially optimize the data flow down to the end user. And we do that for every single end user on the internet. This is where our algorithms are taking shape. So first thing, let's talk about the route selection. So we talked about how BGP, the governing protocol for routing on the internet, is not the most efficient protocol when it comes to performance. And there's problems that can happen when you route through the internet, right, that are just basically out of your control. The way Akamai goes about and solves this type of problem is with a feature that we call SureRoute. And what SureRoute does is literally takes alternative paths through Akamai's distributed servers, right, and basically gets around those bottlenecks, right? So going back to the example that I talked about earlier of getting directions from New York down to Washington, D.C., right? Now you actually have a way to basically, when you hit those bottlenecks, to get around them, right? So when you, just like in that example, when you come across an accident, now you know what the local roads are to move around. And that's what Akamai is doing. We're finding other public internet routes that are least congested but are faster, right? And we're able to move data down from your cloud environment to the end user faster, or even upload data from the end user down up to the cloud environment faster, right? It works both ways. So the next thing that we do is reducing the number of round trips. So TCP is also a protocol that the internet is based on, right? And TCP is a very conservative protocol, right? It involves a handshake to establish the connection to ensure reliability. That's the upside of using TCP. The downside is the conservative nature of it. TCP, the way it works is it starts out by serving a small amount of data once the connection is established, and then gradually ramping up to the peak throughput, right, that connection can actually support. Right? That's good for reliability, but it's also bad for performance. And when you think about TCP, it was designed in the 70s. It wasn't really designed with the consideration of the high bandwidth connections that are in place today. A lot of connections can handle more traffic, right, in a faster period of time, and we take advantage of that. So when Akamai is in the picture, we utilize our communication protocol to essentially, one, ensure that the connection is established as quickly as possible, right? And then two, once the connection is established, push more data through our servers down to the end user to reduce the number of round trips that it takes to move data from the cloud environment down to the end user. That reduction in the number of round trips improves performance down to the end user. So the next thing that we do is employ prefetching. So we know that when a browser loads a page, it first parses through the HTML and goes and fetches the embedded objects of that page. And many of you may be familiar with, accessing a web page, and pulling it down and seeing it gradually load top down on the page. That problem occurs because the browser is fetching objects and they're just not showing up in time. It's going all the way back to the infrastructure, grabbing those objects, and it's just taking a long time. What Akamai can do is, if Akamai is in the middle of this transaction, what we can do is fetch the HTML page, parse it, and then as we're delivering it down to the end user, go and fetch all those embedded objects, pull them into memory, and then by the time the end user requests them, we can immediately deliver them back from that optimal server that we talked about. What we can also do is this subsequent page that you think the end user is going to access next, we're able to go and fetch that page too, even if it's a dynamic page. We could take the session information, the cookie information, be able to go and get the subsequent page, load that into memory. So if that takes a long time, or if that takes, has some long back-end think time, right, we can pre-process that, generate the page, get it down to our edge server faster, and the result is a better experience for the end user. So here's some sample data for a test that we ran for a customer in March. This is a Gomez transaction test, a 4-step transaction test. The yellow lines represent data for an application accessed over AWS, and the response times for that application for those pages going direct. The blue line represents the Akamai results, so you can see a clear difference in the response time that Akamai provides from these globally sets of agents. The bottom graph represents a histogram of the response times if you categorize them in buckets, right? So how many transactions completed within 2 to 4 seconds, 4 to 6 seconds, 6 to 8 seconds, right? And we're counting those up for the origin, and we're counting those up for Akamai. And you can see that there's a shift there in the graph. More of the Akamai lines are over to the left, meaning that there's more of that transaction that completed in a shorter period of time. Whereas if you went direct, there's more of those transactions that were just over very wide-ranging periods of time. And it's no criticism of the platform that it's running on, but rather of the internet itself, right? And this is why we say that we provide a complementary solution, because we're optimizing that medium that is connecting your end users to the cloud environment. So one of the things that to keep in mind is performance. At the end of the day, it's great for your end users, but it's also important for your business, right? From an end user standpoint, if their experience is good, they're going to adopt the applications. You're going to provide that reach. Their productivity is going to go up, right? Your productivity also goes up too, because you're not dealing with problems as well. It could also eliminate costs, right? It could also mitigate the need to building out more infrastructure, because you could be running on a distributed platform, right? That can reduce costs and reduce overhead. These are the main business drivers for why people utilize Akamai for the performance capabilities. So now I'm going to talk about availability and what we can do there. If you have an application running through Akamai's platform, end users make the request for that application first and going through the Akamai server. Then they make the request to wherever it's hosted. And this is all based on rules and a configuration on the Akamai environment. We know where to fetch the elements for this application. If, let's say, the route is down going to that first cloud provider, right? We can detect that in real time. Our servers can have rules in place that say, if it takes longer than, say, a quarter of a second or a half a second to get a response back from the origin, immediately fail over to the secondary location. And let's say that secondary location is a private environment, your own corporate environment. But what if you're doing maintenance on that environment? We can detect that as well. Okay, we just got a 500 response code back from that provider. Again, capture that, and then in real time, fell over to a tertiary location. Right? This is just a description of what we can do from a failover standpoint. It's also part of a demo that we're running here at Cloud Expo, and everyone can even access it live right now by going www.akamlab.com to kind of see it in real time. And if you want a better or a more detailed description of what that demo is doing, you can come to our booth. But what we can also do is balance the traffic across these different environments. Because we're sitting in the middle, now you can say, hey, I want 60% of my traffic going to Amazon, I want 30% to my corporate headquarters, and then 10% over to Rackspace, or any sort of variation of that. What you can also do is ensure affinity. So if a session is established, say, with your corporate headquarters, right, making sure that that end user's request always goes back to the corporate headquarters during the life of that session, right? These are all rules that can be set up on Akamai and be utilized through our platform. Oh, and that's something that we call Akamai cloud balancing. So now let's talk about mobile. So when thinking about mobile, it's really important to keep in mind that end users are accessing applications from many different types of devices, from many different types of connections from all over the world, right? And then obviously, as the type of connection they're accessing from, the latency itself is actually impacted. So if they're coming over 3G, it's very different than if they're coming over 4G or even over Wi-Fi, right? So if you can take this information into account, you can impact the user's experience to that application. And if you look at the different types of devices that users are accessing applications from or accessing any sort of websites from nowadays, they're widespread, right? There's different CPU, there's different memory. Some of them support different types of protocols. They have different browsers running on them, all having a resulting different experience. If you can take all of that into account, you can now cater the experience to the end user and make sure it's optimal. At Akamai, what we have is a technology we call front-end optimizations. It allows us to essentially optimize that HTML page and optimize those assets for the type of device, for the characteristics of that device, for the browser that device is running, and even upwards for the connection, right, that device is coming from. Optimize the experience and making sure that not only those assets are traversing the internet as quickly as possible, but once they get to the end user, they can be rendered as quickly as possible on that device as well. So now we'll quickly touch upon security and visibility. So from a high level, from a security standpoint, threats are evolving, and we're seeing an increase in the number of denial of service attacks against a lot of our customers. And the denial of service attacks, it's not the only type of attack that we're seeing. We're also seeing an increase in the number of application level attacks that are also occurring. Things like cross-site scripting, things like SQL injection attacks, right? These are also elements that our customers have to defend against. And the types of companies that have to defend against them are pretty wide-ranging. It's not just your antivirus company anymore who's under attack, or your government agency who's under attack, right? It's many different verticals, actually almost every single vertical, any sort of application. You put something out there, you're now vulnerable to attack. Gaming, sporting, tourism, whatever the case may be, right? They're potential targets. And the ways that these threats are evolving is becoming much more sophisticated. Groups are gathering on the internet, and they're becoming more coordinated and more sophisticated in the attacks that they're carrying out. So at Akamai, if you were essentially throwing an application out there on your own, you'd be really vulnerable to these types of problems, right, if you didn't defend against it. So clearly, if end users are going directly to your site, it's very possible for the bad guys to get right in if you're not doing anything to sort of block them. At Akamai, what we can do is Akamai provides a natural defense mechanism, right, against distributed denial of service attacks. Right? Because we are a distributed platform already, you naturally get that from Akamai just by signing up for the service. Right? On top of that, we can even provide more sophisticated security rules. A web application firewall distributed across our servers that can employ techniques to detect the application layer attacks and be able to block those on our edge servers, or even be able to alert you to those types of problems as they're occurring. The other part about this is that we're able to ensure these configuration or ensure these rules no matter where the application is running. Right? Whether it be on HP, whether it be on Rackspace, or whether it be on Amazon. It doesn't matter where it is. These rules are all running out in the cloud. So the next part that I want to get into is talk about big data and how Akamai can integrate with a big data strategy. So from a high level, if you're running an application through Akamai, it's possible for Akamai to report back, provide you a real-time feed of data back to your analytics environment, your Splunk environment, your Cloudera environment, Hadoop environment, whatever the case may be. Right? That allows you to get a real-time view to what's happening no matter where the application is being run, no matter where it's hosted, right? Bringing it back to you. Akamai has partnerships with BMC. We also just signed a partnership with Sumo Logic that allows us to send data their way and provide information back to you about performance or any type of report, essentially, that you're looking for. Right? If you're looking to analyze what it means from a security standpoint or what it means, what users are accessing, now you can get that real-time data feed. So Akamai is now contributing back to your environment. This is all on top of us being able to more reliably transfer big data through the internet using the protocols and using the algorithms that I talked about before. So in summary, I just want to say that these are really exciting times, exciting for the cloud providers, exciting for you all who are adopting the services, and it's also exciting for Akamai. A lot of the challenges that you face on the, with cloud adoption are internet-based. Akamai has complementary solutions to those problems, and they can allow you to save costs and improve productivity. With that, I want to thank you. If you have any questions, you could feel free to come up afterwards. You can email me, you can tweet me, and if you want to get a real-time view to what's happening on the internet from an Akamai standpoint, feel free to download our application on the iTunes Store. It's a pretty cool app that shows you how much traffic Akamai is serving right now. Thank you, everybody, for your time.
Thank you so much, Gary Ballabio. The show floor is now open.